All right, so in this video, let's take a look at velocity and acceleration, and we're given a displacement function or a position function. So first, let's look at this. It says if the position at time t of an object moving along a straight line is given by s of t. So this right here represents the position of a function at any given time. Then the object has a velocity, which we'll represent with v of t is equal to s prime of t, or you can write it the derivative like this, the derivative of s with respect to t. This and this mean the same thing. We're just taking the derivative of our position function. And then it has acceleration, a of t is v prime of t, or we can write it as dv dt. So all this means the same thing as this. It's just a different notation. Basically, all it is we're taking the derivative of the velocity function. So the derivative of the position function is velocity. That's the change in position. And the derivative of the velocity is acceleration. Acceleration, that's the change in velocity. So it says the object is advancing when v of t is positive and retreating when v of t is negative. So if the velocity is positive, it's advancing. If it's negative, it's retreating. And then if the velocity is equal to 0, that means it's stationary, it's not moving. And then it is accelerating when the acceleration is positive, and it's decelerating when the acceleration is negative. All right. So let's take a look. I've got two examples to work. So let's take a look at the first one. It says the position at time t for an object moving along a line is given by s of t equals t cubed minus 6t squared plus 9t plus 5. All right. And then they want us to find the velocity of the object and discuss its motion between times t equals 0 and t equal 4. So what we'll be discussing there is it advancing or is it retreating? Or when is it advancing and when is it retreating during this time interval here, t equals 0 and t equal 4. And then for part B, it says find the total distance traveled by the object between times t equals 0 and t equal 4. And then find the acceleration of the object and determine when it is accelerating and when it is decelerating between t equals 0 and t equal 4. All right, so let's go ahead and work part A. All right, so find the velocity of the object and discuss its motion between times t equals 0 and t equal 4. All right, so we have s of t is equal to t cubed minus 6t squared plus 9t plus 5. So let's go ahead and find the velocity, which is just the derivative of the displacement function or the position function. So that's 3t squared minus 12t plus 9. All right. So here we need to do what? All right. We want to know, well, this actually answers the first part of the question, find the velocity of the object. All right. So we get v of t is equal to 3t squared minus 12t plus 9. This is your velocity. Okay. That answers the first part. Now they want us to discuss its motion between t equals 0 and t equal 4. All right, so in other words, when is it advancing and when is it retreating is what they want to know. So we need to set the velocity equal to 0 and solve for t. So if we take 3t squared minus 12t plus 9 equals 0, well, we can divide each term by 3. So 3 goes into 3 one time, so that's t squared 3 goes into 12 4 times, and then 3 goes into 9 3 times, and then 3 goes into 0 0 times. Okay. All right. So then if we factor this thing, I get t minus 3 and t minus 1. So t equals 3 or t equals 1. So what I want to do here is I want to plot this on a number line, 1 and 3. And that's going to break this up into 3 different regions. And what I'll do now is we will choose a number from each region. So let's do t equals 0, t equals 2, and t equals 4. And then take the t equals 0, and we're going to plug it. We need to plug it back into the velocity function. You can plug it into this one, or this one. Okay, it doesn't matter. All right, so it's easiest just to plug it into here. So look at this. If I replace t with 0, I get -3 times -1. Now, I don't really care about what the exact answer is. All I care about is it positive or negative. So if I plug 0 in, I've got a negative times a negative. That's positive. And then if I plug the 2 in, well, 2 minus 3 is negative. 2 minus 1 is positive, so a negative times a positive is negative. And then if I plug the 4 in, 4 minus 3 is positive. 4 minus 1 is positive, so a positive times a positive is positive. All right. So what does this tell me? Okay, so I'm going to erase this so we'll have some room here. All right, so let's take a look at this. So the first thing I want to do is I want to look at each interval. I need the sign of the velocity, and then I can describe the motion. Okay, so in this interval, if t is between 0 and 1, that is positive. Now, why did I choose 0 to 1? Okay, why not -infinity to 1? Well, because the only time intervals that I'm interested in is from 0 to 4. So if I put my 0 here, I put my 4 here, I'm just worried about this interval, this one, and this one. Okay, so see, I can see, yeah, from -infinity to 1, it's positive, but all I care about is 0. So I know from 0 to 1, the sign of the velocity function is positive. And then I know from 1 to 3, so 1 less than t less than 3, that sign is negative. And then, look, from 3 all the way to infinity, the velocity is positive. But all I care about is 4. See, that's where it cuts off at 4 here. So from 3 to 4, the velocity is positive. All right? So now let's describe the motion. Well, I know in this interval, since it's positive, that means it advances. Now I'm going to abbreviate that. Okay, well, I'm going to just put A for advance. All right, and then I know from 1 to 3, since it's negative, that means it retreats. And then from 3 to 4, it advances. Okay, all right, so when does it advance? It advances from 0 to what? To 1, right? From 0 to 1. So if I do the description of the motion, okay, so that's going to be, I want to see about the position of the function, okay? So this is going to be s of 0, okay? So it advances from s of 0, okay, from this position to s of 1, this position. So it advances from this position to this position. Okay, does that make sense? All right, So how do I find this position here? Well, I take the 0 and I plug it back into my position function. So I'll do it on this one, but I'm not going to show all the work on all of them. So that's 0 cubed minus 6 times 0 squared plus 9 times 0 plus 5, which equals 5. So from this position, s of 0, which equals 5, to s of 1. So for s of 1, I would put 1 cubed minus 6 times 1 squared plus 9 times 1 plus 5. And that actually equals 9 if you put it in your calculator. So it's advancing from 5 to 9, the position. Okay, it's advancing. Then it's retreating from what? S of 1, which equals, well, we figured that out here, 9, to what? S of 3. And what's S of 3? Well, if you take the 3 and plug it back into this position function, you get 5. And then it's advancing from S of 3, which we just figured that out, is 5, to S of 4, and S of 4 is actually equal to 9. You take the 4, plug it in for t, and plug it into t into the position function, and that gives you 9. All right, so that's a description of the motion. Okay, and we can actually kind of summarize this in a diagram, and I'm going to erase this and I'll sketch the diagram right here. All right, so for the diagram, if I draw a line here, okay, and let's call this 0, we'll call this 5, and we'll call this 9. All right, so we have a point here. Okay, so we're starting here. We've got S of 0. Okay, that's from time t equals 0 to t equals 4. And if you can see, at 0, we're at 5. And then as we move to S of 1, we're at what? 9. So we go to here. So this is our S of 1. All right, so we're advancing, and then when we get here, okay, so let's look at this. Let me draw that a little better. All right, so we're coming here, we're advancing, and then all of a sudden, when we get to 1 to 3, for t equals 1 to 3, it turns and it retreats. Okay, this right here is S of 1 is 9, and it retreats until we get to S of 3. Well, where's S of 3? It's at 5 here. So here it's going to turn around again. This is S of 3, okay, and then from 3 to 4, it's advancing, so it's turning back around and coming this way, and that's where it stops at S of 4. Okay, and that's the only time interval that we're interested in, from 0 to 4. Okay, and you can see at 0 we're at 5, at 1 we're at 9, at 3 we're at 5, and then at 4 we're at 9. Okay, so this is advancing, retreating, and then advancing. So that takes care of part A. Now let's look at part B. So I'm going to erase this. All right, so part B tells us find the total distance traveled by the object between times t equals 0 and t equals 4. All right, so the object travels from what? From S of 0 equals 5 to S of 1 equals 9. All right, so the distance, so this is part B. So the distance is equal to, well, what's that distance from 5 to 9? Well, I subtract this distance and this distance. So it would be this distance minus this one. So that distance is going to be 9 minus 5. And then look at this. I take the absolute value because I'm talking about distance, and we know that distance it's got to be positive. So that's where the absolute value comes in. And then plus, now I'm doing what? I'm going from this distance to this one. See, just like here, I went from here to here. And what did I do? I did this one minus this one. And same thing here. I'm going from here to here. So I've got to do this minus this. And I have to take the absolute value. See, if I didn't do that, I would get a negative. Okay? But we're looking at the whole distance traveled. If you remember, our diagram looked like this, right? This is what our diagram looked like. See, it was advancing, retreating, advancing. But look, if I just added these up, well, this one and this one would cancel out because one's positive, one's negative. But see, this right here is still a distance traveled. So that's why we take the absolute value to get that distance. Yeah, this is negative, but it's just negative in the other direction. Okay? And then I've got plus, and then I'm going from here to here. So it's this one minus this one. And I do the absolute value. And so this is going to be 4 plus 4. Well, that's negative 4. And then I take the absolute value, which would be positive 4 plus 4. And that gives me 12. And yes, the problem doesn't give us units. If we were talking about feet or meters, that would be 12 feet or 12 meters. Okay. All right. So now let's take a look at part C. Let me erase all this. All right. So for part C, it says find the acceleration of the object and determine when it is accelerating and when it is decelerating between t equals 0 and t equals 4. All right, so I need the acceleration function. Well, if you remember earlier, we found the velocity, and that which is the derivative of this. So I'll write that down real quick. That's 3t squared minus 12t plus 9. So the acceleration, well, that's the derivative of the velocity. That's 6 t minus 12. And so I want to know, when is this thing accelerating and when is it decelerating? So I'm going to take the 6t minus 12, set it equal to 0, and that's going to give me t equals 2. All right. So then what I'll do is I will plot the 2 on a number line, and I'll choose a point here, t equals 1, and let's do t equals 3. You can choose any numbers you want, so just as long as they're in the intervals. You got to pick a number from each interval. All right, so let's plug in the 1. We'll plug the 1 into the velocity. To the acceleration function. So if I plug the 1 in, that's going to give me 6 minus 12. That's negative. If I plug the 3 in, that's 18 minus 12. That's positive. Okay. So what that's telling me is the particle is accelerating from where to where. Okay, accelerating. Well, let's go ahead and write accelerating when a of t is positive, right? So when is a of t positive? Well, that's from 2 to what? Infinity. But remember, I'm only interested in the times from 0 to 4. So let's go ahead and plot a 4 there and plot a 0 here. So it's accelerating from what? From 2 to 4. All right. And then it is decelerating when a of t is less than 0. Well, when is that? That's when it's negative, which is from 0 to 2. So it's decelerating from 0 to 2. And this is what they're wanting. Well, actually the whole thing. This is what they're wanting for part C. All right, so I got one more example. This example won't take as long as this one. This one was pretty long. But let's look at this one. All right, so S of t is the position of a particle moving along a straight line at time t. Find the velocity and acceleration of the particle, and then find all times in the given interval when the particle is stationary. All right, so let's look at part A. So I've got S of t is this function here. So they want us to find the velocity and the acceleration. So remember, the velocity is the derivative of the position function. So the derivative is 3t squared minus 18t plus 15. And then they want us to find the acceleration, which that is the derivative of the velocity. So that's going to be 6t minus 18. So I get the velocity is 3t squared minus 18t plus 15. And the acceleration is equal to 6t minus 18. And this is the answer they want for part A. So now let's look for part B. Let's solve part B. Find all times in the given interval when the particle is stationary. So what does that mean? Stationary. That means it's not moving. When is the velocity 0? So to find this, we just take the velocity function and set it equal to 0. So that's going to give me the velocity function, which is 3t squared minus 18t plus 15 equals 0. So to solve this, I'll divide each term by 3, because 3 goes into everything, make it easier to factor. So that's going to be t squared. 3 goes into 18, so 6t. 3 goes into 15, that's 5, equals 0. So then if I factor this, that's t minus 5, t minus 1. And so I get t equals 5 or t equals 1. All right. So once again, they didn't give us the units in this, but that if it's seconds, then it's 5 seconds. If it's 1, it would be 1 second. Well, look at this. 1 and 5, they both fall within this interval. You have to make sure you check when you get your t values. It's only the ones that are in this interval here. Okay? So be careful with that. Now, one other thing I want to mention is the units. I didn't really talk about that, but I do want to come back up here and let's mention the units. So let's just say that the position is measured in meters and the time is measured in seconds. Well, the velocity would be written as meters per second. That's how you would write your units. And then if I'm dealing with acceleration and I'm in meters and seconds, that would be meters per second squared. Okay, so that's the unit. Or if it's feet in seconds, that would be feet per second and feet per second squared. All right. So I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. And thanks for watching.